I want to get to, we could spend forever in the day on triple integrals, but there is a couple of things I want to do. I want to just do one more of these guys, setting up a triple integral. This is similar to question 12. Then I want to talk about center of mass in 3D and how you would calculate that.
I do have a question.
Sure.
On 15.6, which is what we're working on right now, I was doing number 3, and it says evaluate the integral. When you evaluate the integral rather than finding the volume, especially if you're evaluating a triple integral and you have like sine and cosines in there,
sure.
The actual evaluated number can become negative, right?
Correct.
Okay, because I'm getting a negative answer every which way I do it. I haven't submitted it online yet, but I was just making sure I could have a negative answer that way.
You can have negative. It doesn't mean you did it right, but you can have a negative. I'm looking at my solution, which might not be yours. My solution is positive, but
Number
you can
3?
have negative.
Okay.
I mean, if you want to think of a very simple example of how you might get a negative, how about from 0 to 1, 0 to 1, 0 to 1 of -1 dx, dy, dz?
Mm-hmm.
That answer would come out eventually as -1.
Okay, because once you integrate the square root of z with the u sub, I get -1/2 times the 2/3 to the 3/2 u.
Right.
And then just evaluated from 0 to 2, I get, at the end, I get -8/3 times 2 from the negative cosine.
Mm-hmm.
Yeah.
So
I mean,
-16/3.
Question 3 varies. So the one I've got is positive, doesn't mean yours. So you got a negative as well, Jay?
Yeah, I did. Yeah.
Did it say okay?
Yeah, it was okay.
Right.
Okay.
So you negative is good to go.
Yeah.
Okay.
It's just that yeah, it's very confusing because I went back on it like almost like 20 minutes just to make sure I got it right and everything was right and I submitted and it was okay. But yeah.
And to kind of wind back a bit or circle back to what Brooke was saying, if your question was find the volume, so it will be the triple integral of 1 dv, right? If your question was find the volume of this shape, that must be positive because that is a physical thing in 3-dimensional space, right? It's a number that has to be positive. It makes no sense in that context to get negative. But if it's just any old triple integral that just happens to be thrown at you, 0, positive and negative are just as likely, right? All things are equal. Okay, let's look at this guy. Not going to do the whole question because I think the hardest part of a triple integral is finding E, right? Setting up the limits of integration. Because once that bit's over, it becomes pretty mechanical, in my opinion, at least. Okay, so in this particular question, we're being asked to do the triple integral over a region E. It's a function, so it's 5xy dv. We know then that we're going to have to do these fellas, then it's going to go 5xy, and then I'm going to have to figure out which one goes where. Now, in this question, you're told y equals x squared, x equals y squared, z equals 0, and z equals 7x plus 5. So I'm going to work on this piece of information first. It contains x's and y's, so z equals 0 to 7x plus y. I'll be comfortable about the limits of z just using those two things. Okay, happy, not happy? Right, happy.
I'm happy.
Right. Now, there are so many things you could get. It's not a one-off, one shoe size fits every shoe kind of thing. In this case, we have this piece of information. I want you to imagine that the shape, this entire region, is now dropped onto the floor, right? The z equals 0 part. And if you take this shape and you drop it onto the floor, basically, isn't this the fellow you're working with? Now, if I put him in, y equals x squared looks like this guy. And if you rearrange this guy, y equals the positive square root of x. Okay, So we are talking, we're talking the banana shape thing. Now I look at this guy and I want to describe him, that guy there, by the way, is 1. I would describe it as x being from 0 to 1. And then wouldn't y be from the top curve, which is the square root, to the bottom curve, which is x squared. So you put this package together, you've got x goes from 0 to 1, y goes from y squared to the square root of, well, x squared I should say, to square root of x, and z goes from 0 to 7x plus y. So this guy fits here, which means I'm going to do the z first. Would you agree that this middle one has x's in it, so it goes in the middle? And this is going to be a y on the bottom of x squared and a y of square root of x on the top. And then the x's go at the end, which I hope I got this right. Did I get that right? Some looks wrong here. And I did get it wrong. Can anybody see? It's just a minor thing, so it's easy. I can fix it very quickly. I've got a need.
The z limits should be opposite, no?
No, that could happen, but that wasn't it. No, it's to do with the x's. I'm looking at the solution, and it dawned on me. I'm going to curve this guy up. No, I'm actually not happy with their answer. I like my answer. I mean, if I continue this shape, it just curves around like this, right? That's what x equals y squared looks like, right? Because it goes both ways. And then y equals x squared goes that way. Oh, I'm sticking to my guns. That's actually good. I don't like their solution. I like this one better. Of course, I'm looking at the wrong bloody answer. That explains it. I was right all the time. Okay.
Just blame your eye. It's your tracking issue. It's okay.
You know that. I must have told you I've got one good eye, right? So I do have problems tracking because of that. Okay, then that's fine. I screwed up by looking at the wrong one, but no biggie. Now, if you take this fella in all its pieces, aren't you just going to integrate this with respect to z? That's going to get you some x's and y's. You're going to integrate with respect to y. So y is going to go in the middle, and then you're going to finish off with some x's. Are we okay with that setup on that question then?
Yes.
Right. So good luck with the others, but we have to move on. So there's one last thing in this section, and it's the centre of mass. And I think, I don't know where I am right now, so there we go. What we need to do here is imagine what we've done in the 2D world. Why is that not pointing the right way? Come on, there you go. If you can imagine in 3D shape, right, a blob, whatever it is, right? That's a 3-dimensional shape. And at any given point inside that, there is a density function, right? So the density function would represent the how dense the material is at that given point. Right? Then you would want to know the center of mass of this object, because center of mass tells you all sorts of useful things about the stability of the shape. In fact, I believe in physics, if you know the center of mass, can't you put the entire mass at that point and just have it pointing downwards, and it can make calculations easier because you only need to look at one point in space rather than an indiscriminate blob in space. If you are building a ship, you want the center of mass to be in the middle of the ship, and if possible, as low down as possible on the ship. So here's my little ship. In fact, here's my aircraft carrier. See, little plane there. It's probably pointing the wrong way. If you are building an aircraft carrier, you want the center of mass to be in the middle of the ship and as low down as possible. If the center of mass is too high up, that will make this ship, this aircraft carrier, unstable, because if it moves, it could tip over. If you make the center of mass too far forward, as it travels through the sea, it will be digging into the sea, won't it? Its bow will be hitting low, and that will reduce its ability to go at an efficient speed. I'm not quite sure what happens if it's too far to the back. Imagine the ship travels this direction. I guess if it travels too far in the back, won't the back of it be sticking into the water a little bit more and the top would be up? And for an aircraft carrier, that's probably a bad idea, because it means that you might be taking off uphill, but you'll be landing downhill. I'm not sure that's a good idea. So you can imagine you want to know where that center of mass is. And Brooke's not going to tell us anything because this is a secret, but you will say yes to this. Is center of mass something that people in the ship industry like to know about things when they stick them on boats?
For some of the things, yes, if it's a certain weight or going where it's going, but they do have to understand where the center of mass, where the boat would be fully loaded, and how they distribute the weight. They have to know it for that reason.
Right, and there are ways to do it. You can fill tanks of water, move the center of mass accordingly.
That's what they generally do on submarines.
Yeah, so I've sold you that you need to know these things, I hope. So what the heck does it look like? Well, here it goes. X bar, Y bar, Z bar. Because obviously the center of mass is a three-dimensional object, is a coordinate in 3D. And it's 1 over the mass, the triple integral of X times density, Y times density, Z times density. There is something very elegant to me about this formula. Isn't there an awful lot of symmetry in what you do? Right?
Correct.
The X coordinate is X times the density. The Y coordinate is Y times the density. What is cool about this is that nobody that I know of, at least, can imagine a fourth dimensional object. But I bet you I could tell you the coordinates of it. If we call the fourth dimensional W, won't it be 1 over M? Well, it'll be a quadruple integral, right? But it'll be 1 over M, a quadruple integral of E, W, density function, X, Y, Z, W, right? Can you increase the variables to as many dimensions as you feel like? I have no idea if anybody has ever tried to calculate a fourth dimensional center of mass, but at least mathematically it's doable. So let's look at an example of that. The one I'm choosing is like question 13. And the describing E as this guy here, which is a parabolic cylinder according to them. And I'm not going to argue with them. If they call it that, that's what it is. A thing that looks like this, which is clearly a plane. I realize that. X equals 0. What else do we have? Z equals 0. And a density function, which is actually just a fixed number Z. But couldn't that density function be anything you like? You know, X, Y, Z, X plus Y plus Z, things like that. So we have to figure out how to get these things. And before we figure out these things, we first have to figure out the mass.
Is the density function 7 or 7Z?
It's 7. Is it 7Z in yours? It's 7.
No,
and
I was just...
Yeah, it's just a number 7. But what I was saying is you could have a density function, anything you like. Couldn't the density function be this fella? Which would tell me that the further away from the origin you get, the denser the object is. That would be a density function as well. So they tell you that. That's probably not going to be the guy that's going to cause us trouble, right? He's just going to 7, 7, 7, 7, right? He's pretty much not the issue. To me, the issue is getting E. So we have to figure out how to get E. And I've got my little notes set up here. Okay, we got a lot of information, but I would say that these two guys here seem to be the most interesting because they've got stuff in them. So I'm going to take z equals 1 minus y squared, and I'm going to take this fella. Oh, and z equals 0, sorry. And I think I've already got one of my limits, one of my regions. If I use, I'll call these 1, 2, 3, 4. If I use number 1 along with number 4, that's the range of Z. Are you comfortable about why I chose those two? I want a start and a big. Now, could these be switched? I guess they could be, but it wouldn't be hard to figure out. Couldn't you plug them into a calculator and GeoBrown and look at them? The one that's biggest goes, at the ends. The one that's smaller goes there. Pretty sure that's the right order, but I may change my mind later. Okay, now, if that's Z out the way, I still have to figure out what to do with the x's. So let's put this guy in and this guy in, right? If you rearrange this fella, this one here, don't you get x equals 5 take away 5z? So I now have x equals 0 to 5 take away 5z. So that's me using 2 and 3. The x equals 0 is a giveaway. What I've done is I've just taken this and rearranged it and got x in terms of z. Right, I need a y now. It's the only guy left. And I'm going to use 1 and 4. 1 says that z is that, and 4 says z is that. Right, basically this. But if I replace z equals 0 here, I get that, which means I get that. So that tells me that y is between 1 and -1. I have now created E. So let's see if we can figure out what the mass would be. It's the triple integral of E of the density function dV. Okay. Z goes from 0 to 1 minus y squared. X goes from 0 to 5 minus z. Y goes from -1 to 1. One of those three goes here. Which one is the last integration to do?
By y.
So y equals -1 to 1, stick a dy there, right? So can you imagine that disappears? Now I got to figure out, either I got to figure out who goes here or I got to figure out who goes here. It really matters. I just have to figure out which one goes where, right?
Z would go in the middle because
Say
it's
again?
defined by y. Z would go in, Z would go in the middle because it's defined by y. Y squared.
Oh, I got you. So you got a 0 and a 1 minus y squared, and then the x's have to go here, and that is going to be 5 take away 5z. So that means I do z. No, I don't. Sorry, I do x, then I do z. Right? That is correct. Now, some of you might be looking at that and thinking, why can't I do it the other way around? I mean, why can't I put the x0 to 5 minus 5z and the z equals to here? This guy's got z in it. Won't that mean this integral will have z in it? When you come to this integral, won't all the z's just turn into y's? You see that order makes sense? The variables will disappear. If you switch places, if you did this integral with that guy, won't you have 1 minus y squared in it? Then if you do this integral, aren't you going to have z's left over that you can't get rid of? So we all know that the numbers go here, right? I guess you've got two choices. If you think it through, you should be able to figure out which one makes more sense. If you unfortunately choose the wrong one, I think you'll find out pretty quickly it's the wrong one. How come I've still got 5z left over? Where's that y cubed coming from, right? Things like that are going to happen. And you're going to go, okay, I must have done these two the wrong way, and you switch them. Now, this is as far as I want to go in this thing. Can you imagine that we did this? And since I love the number 42, we're going to imagine that the answer was 42. And if it is, that's a miracle, right? So to get x bar, isn't it 1 over the mass? X times the density function, so 7x. And can you imagine you integrate 5 minutes later, you get the answer 1, because I've just decided it's going to be 1. Then you do the y bar and it's 2, and then you do the z bar, then it's 3, and you now know the center of mass. Are we good? I didn't really do the details. The only thing I really spent any time on is what I consider the hardest part, right? If you can set up these limits of integration, that to me is the hardest part, right? The question is finished, isn't it? Just a matter of plug and chug. Integrate, 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 get 42. Or 1 or 2 or 3, whatever it ends up being. You're not going to see this much, at least in the questions I very superficially scanned over that are like this. You're not going to get this happening, but when it does, it is really cool. Do you know if you recognize that the functions are symmetrical? You know, like x squared plus y squared plus z squared, right? Got that kind of look to them. And that the limits of integration are somehow symmetrical. If you find x bar, couldn't y bar and z bar be the same guy? So you kind of only need to find one. Now, the types of shapes that that's likely to work with would be, can you imagine a sphere floating in 3D space? And that the density function is in some way symmetric. If that happened, I pretty much can guarantee I already know where the center of mass is going to be. Isn't it going to be at the center of that sphere? But if I had a cylinder, wouldn't the center of mass be somewhere through the vertical spine of that cylinder? If everything else was symmetric. So sometimes, just sometimes, you get really lucky and you get to cut out some of the workload.
So if we had like this question and we get the X bar and we realize that the whole entire thing is symmetrical, couldn't we just do the same symmetrical?
Yeah, you can just say, let's say X bar is 42 and you know that the thing's symmetrical, which is rare, but if you get it, you go, great. You could write down X bar is 42, Y bar is 42, Z bar is 42, brackets, symmetry, close brackets.
Okay, I just wanted to make sure that that would still apply to.
Yeah, that would
This
be
as well.
valid. Right, now, what about this fella? I want to set up E for X is 0, Y is 0, Z is 0, and X plus Y plus Z equals 4. And we really need to figure out what the E would be for this question. I believe the reason you need to do that is that it's part of a center of mass question, which is fine. Okay. Which one of these pieces of information do you think is the most useful for setting up limits of integration?
The plane.
Yeah. Now, if you rearrange this equation, isn't Z 4 take away X take away Y? And if I put it with this guy, basically I now have, although if you put it into GeoBra, you might find out that it's 0 here and the other guy there. And you know, that's what visual is, right? You can plug it into GeoBra and say, this plane is actually below the floor, right? Not above the floor, which case switch places. All right, done it. Well, if I have used this thing up, what we've now got, if I use Z equals 0 at least, is we now have this relationship. Right, basically dropping the thing on the floor. Now, when I see that, I think of this guy. And since X is 0 and Y is 0, aren't we basically getting a little triangle? So this is a straight line with the equation 4 take away X, I hope. From here, I can tell you that the X's go from 0 to 4, and that the Y's go from, there's my vertical, Y equals 0 to there. And that's me got my guys. I'll put the Z down here. Are you happy about how we created E in this question? So when you're setting up your triple integral, let's say to find the mass, you're going to have a density function here, whatever it happens to be in the question, I can't remember. I'll call this guy 1, I'll call this guy 2, and I'll call this guy 3. Which one of these 3 goes first? Which one of those 3 things do you integrate first? It's not meant to be a trick question, honestly.
Z.
Yeah. What made you choose that one? It's the right one.
It's the one that has the most independent variables.
Correct. And for that same argument then, wouldn't you pick 2, which is the Y value? In fact, don't you always pick the numbers to go to the end? So when you're deciding what order it's in, isn't one of them the numbers the easy one, right? He's always going to be here. Boom. And then you'll have a kind of choice thing, right? In this case,
Generally,
that guy and that guy.
Rule of thumb to say that the one where the limits include 2 variables should go first, and the one where the limit includes 1 should be in the middle.
Correct. I think I wrote something like that then, but you're exactly right. In earlier notes, we did that. Now, if you get, I think, a previous question where this one has X's in it and this one has Y's in it, right? So it's not so obvious. can you imagine it would go 0, y, 4 minus x, and 0, z, 4 minus y. Now, imagine that could happen, right? Now, both of them have one independent variable, right? So there's no 2, 1, none kind of thing going on, but we still have to figure out which one goes first. So which one goes here, essentially? Which of these two should go here?
The Z one?
Yes, correct. Do you see why you chose that one? Won't the Z's generate Y's, and then won't the Y's become X's, and then the X's disappear? Do you see there's a kind of this becomes that kind of flow to it? If you switch places, if you did Y's first, X's would be transferred. And then the Z wouldn't get rid of those X's, they'd just be transferred into some Y's. And at the end, you'd end up with some variables with no home to go to. Okay, that is the end of 15.6. Any questions about it before we move on? Okay. Now, let's show you a new coordinate system. This time we're talking about triple integrals, so it's 3D, and there's a coordinate system called cylindrical coordinates. And in another section, there's another coordinate system called spherical coordinate system. But we're looking at cylindrical coordinate systems. So let me show you what that might look like. If you can imagine a point, what we call Cartesian, right? X, Y, Z. 5, 3, 2, right? Pretty common way of telling someone in three-dimensional space where something is. In cylindrical coordinate system, you drop this guy down until he hits the XY plane, right? Until he hits the floor. And that distance is Z. Would you agree it's Z in both cases? Right, from the floor to the point, right? That's Z. And what they do then is you join a line to here and you measure the angle, which we call theta, and you measure the distance, which we call r. Isn't a bit like polar for the x and y's, and z stays put. So if you convert a triple integral that uses x, y's, and z's into a triple integral that uses cylindrical coordinates, all the x's turn into r cos thetas, all the y's turn into r sin thetas, and that's exactly what you do when you do polar. Remember, two double integrals, right? And z is still z. And when you do that triple integral, the x's turn into r cos theta, the y's turn into r sin theta, and the z's stay put. And I somehow forgot my d. dz r dr d theta. Do you recognize this funny little guy at the end? Do you notice there's a little r there? Is it not the exact r that you got when you did double integrals converted to polar? So think of cylindrical coordinate system as you use polar to get to here, and then you just go up whatever z is. Now, in some integrals, some triple integrals, converting the integration into cylindrical coordinates can make your life a lot easier. Can you remember in double integrals, it was really nice in some cases when the area, right, the floor was a bit of a circle, right? Wasn't it much easier to get the integral when you use polar? Well, in cylindrical coordinates, if you have an equation or a region in space where the floor, for instance, is very circular, right? So can you imagine a region in 3D space like a cylinder, right? It's got a full circle and then it goes up a bit, right? Or it's got a full circle with a slant to it, right? Some kind of shape, but at least there's a circular base to it, right? Or half a circle. Those are the best candidates for cylindrical coordinates, because very often you can convert the region E into much nicer, easier to deal with limits than it would be if you were full of square roots of z's minus x squared minus y squared kind of stuff. Now, there are some relationships that are very useful. Can anybody remember what x squared plus y squared would look like in this coordinate system?
R squared.
And for that same mar, sometimes you have to deal with that guy, and it's R. Do you agree? Are there any questions about this coordinate system, or do you feel quite comfortable about it's just a different way of telling you where something is in 3D space? I'm looking for worried faces or happy faces. I'm getting non-committal faces right now. Okay, I got a smile. That means we're good. Well, maybe it doesn't. I'm assuming it does, right? I'm going to have to close this fella off. And where the heck are you? Here we go. Oh, shooting space. Okay, you're going to have to wait a little bit longer. You know, it's quite annoying when you get timed out in WebAssign.
Yeah, it is.
But there is no way that, so it happens to me too. There's no way I can stop it from doing that unless I remember to go back and click on it a couple of times. Okay, almost there.
I think will happen, like, is a stranger going to steal into my house and do my calculus homework? 'Cause
Well, we can but hope.
they could do a couple problems if they got the answers right.
Yeah.
I have a question about an example yesterday, which was triple integrals number 7. And the domain, I guess, was bounded by a region that was circular, sort of. It was like a, maybe I should graph it. Sorry, I know you're not in.
No problem, let's do it, because if you have an issue, I can guarantee you're not the only one.
The specific thing I had a question about
I'm allowing you to share right now if you want to share it with the rest.
Oh, well, okay, I can do that. Let me find it. Yeah, okay. I found it, and I will share. So it's number 7 there, where E is bounded by the paraboloid. And how we ended up setting that up was something like this. Let me write it in.
It looks to me that you would project this one onto the YZ plane.
I think, yeah, that's effectively. So the shape ended up being very clumsily drawn. It's sort of like that, like almost a bullet shape. So, and it's cut off by a plane. And how we set up the integral was theta became 2 pi. R was 1 to 0. And then we had
X would go to looks like 2R squared, although I'm not sure what order.
I think we initially had it in there like this, and then R d theta. So what I'm curious about was what we discussed doing was, so we know that X equals R cosine theta, and y equals r sine theta. But yesterday what we talked about doing was y equals r cosine.
Yeah,
And
it's just basically doing polar coordinates, but instead of x and y, doing polar coordinates with y and z.
I guess I'm just confused about how you know which one is which. Like, is there a scenario where z would be r cosine theta?
I think the short answer is it doesn't matter.
Okay, so it just is not that important.
Yeah. You might orientate it slightly differently. You might go 2 pi to 0 rather than 0 to 2 pi. I'm not even sure that would happen. I think it's pretty much interchangeable.
Okay, because I was like confused about how we concluded z's substitution there. And in mine, like in my version of this problem, we didn't even have to do that because it's 7x, and the first one we integrated with was with respect to x.
So that killed off the variable, and it was just a simple.
R substituted right away.
I agree. I understand.
Professor?
Yes.
Okay, I was just confused about how to determine what z was.
Okay, someone else is asking or talking?
Oh, yeah, sorry, I didn't mean to.
No, it's good. Go for it.
I just had a question about that question.
Mm-hmm.
So if it was asking for a region in a particular octant, would it then matter what was y and what was z?
Well, both of them better be positive. Apart from that, no.
Okay.
I mean, I don't think they've never done this. I think they always do the first octant whenever they mention octants, don't they?
Typically.
Yeah, can't think of a second octant, but if you're wondering how octants work, what we would call the first quadrant, second quadrant, third quadrant, and fourth quadrant, they become the first, second, third, and fourth octant. Right? They're the 4 regions above the floor, the XY plane. And then the one directly below the first one is called 5, then 6, then 7, then 8. So that's how you would number the octants if you wanted to tell someone something. So if I went and said something was in the 5th octant, can you imagine the X is positive, the Y is positive, but you're looking underneath the floor? So that would be the octant below the XY plane, right? So it goes 1, 2, 3, 4 is just like quadrant 1, 2, 3, 4. And then octant 5, 6, 7, 8 are just underneath the floor, right? So underneath the first quadrant is where the 5th octant would live. That makes sense? Okay, let's.
Thank you.
Well, okay. I'm not sure what I can do here. I think I might be able to. Yeah. Let's just do some algebra practice at rearranging functions in terms of what they might look like in cylindrical. So if you had 2x squared take away 3x plus 2y squared plus z squared equals 9. I want to rearrange that guy in terms of z. So I'm going to call it 9 take away 2x squared take away 2y squared plus 3x. You all happy about that rearrangement?
Could you please show your screen?
Oh, you would like to see it? Ah, okay. You're just making life awkward. Brooke, you're going wobbly on me. Right. So the question was, convert this information into polar friendly form. Polar friendly form typically means all the x's and y's need to turn into r's and thetas, but z stays put as a z, because z is z in cylindrical coordinates, right? Now, that guy's 9. Anybody want to tell me what that guy becomes?
2r squared.
Agreed? And the 3x, well, nothing very interesting. 3r cos theta. Now, technically speaking, won't that be plus or minus the square root? which means I now know my limits for z. Won't it be negative this ugly square root to plus this ugly square root? Okay, how about this fella? I want to turn that into polar. Ah. That was plus, it would be 9r squared. Obviously, it's not a plus, so I can't do that. Okay, let's do it in stages. Won't x turn into r cos theta? So this will be 9 times r cos theta squared. Take away 9 times r sin theta squared. That's going to be 9 r squared cos squared. Take away 9 r squared sin squared. Now think style points. And is there anything I could do to this expression that might make it look a little bit nicer than it is right now?
I can probably pull out the 9r squares.
I
Yeah.
would do that. Yeah.
Back.
And then sometimes, if you're really lucky, you'll get something you can work with. Sometimes you can't, in which case that's the answer. But sometimes you can. Does anybody recognize the identity, what cos squared take away sine squared is?
Isn't it equal to 1?
If it was plus, it would be, but it's not plus, it's minus.
Never mind, I take that back.
That is cosine through x.
Or in this case, 2 theta, yes.
Yeah, 2 theta, sorry.
So do you see that if you were going to do a triple integral of, let's say, this guy, can you see that the thing would turn into this guy, for example? So part of our process that we'll be doing tomorrow, because that's really when we'll get started on this, is how to take a triple integral with x, y's, and z's and convert the region E into polar, and to convert any expressions that are inside the triple integral. Because you imagine it could be the triple integral of x squared plus y squared. That would be a really nice one to do, right? But it could be the triple integral, you know, of this thing, right? So that's part of the process. One of the nice things about many of cylindrical questions is that typically 2 of the 3 integrals will be numbers, and they'll go something like theta is 0 to pi and r is 0 to 1, right? And it's really just the z's that'll have all the gunk in them. So in a lot of ways, it's a little bit less work. Now, how do you take care of the r's and the thetas? Well, doesn't it really just depend on what does the shape look like when you project it onto the floor? And when you do that, it should be circular in some way, right? And the kind of circulars I'm talking about are the same ones that you used in polar. Couldn't it be a whole circle? That would be the easiest one. Couldn't it be one of those between 2 circly things? Couldn't it be half a circle? Maybe going this way, maybe going that way, right? The same kind of decisions that we made in the double integral world. Remember those guys? Same kind of things are going to be done. For each one of these, won't we be able to do what the r's and thetas would need to be to make it work? So that's going to be a transfer skill, because we've had practice at doing that. And I've overshot your time, which is very valuable to you. So say hi, and I will see you tomorrow. And hang about if you've got any questions, and we'll talk about that at the end. Bye-bye, guys.
I do have a question. In In my assignments, we have section 15.5 for surface area assigned.
Yeah.
Are we just like doing this a bit out of order and we'll go
We
over
are. I'm not even sure I want to do that one, so I'm kind of leaving it hanging.
Okay.
If we take, well, too long's the wrong word, but if we take a long time on some of the sections that are that haven't been done yet, then I will drop it. So just don't even go there. Don't
Okay.
even do the questions. I can pull that out pretty easily if I choose to.
Okay, I just wanted to make sure I hadn't missed.
No, you hadn't. If we go through it quickly, then I will probably put it in as a slightly out of sequence double integral kind of application. Right, you want to find the surface area rather than the volume. This is what you do. You could learn how to do it on your own pretty quickly. It's just a blinking ugly formula.
Okay. Thank you.
Okay, is that it?
Yep.
G, have you got? Oops, sorry. G, you got a question?
I'm good. I'm
You're
gonna
good?
work on that. I think talking to you earlier just kind of gave me an idea, so I'm just gonna try that out to see if that works.
Right. Yeah, I've got a feeling that your problem is setting up E, the limits of integration.
Yeah.
I think once that's done, it's a little bit more straightforward.
Okay. Yeah, I'm gonna try something. If that doesn't work, then I'll just help them.
Okay, Travis.
Thank you.
You're welcome. Travis or Brooke, either of you got a question? Oh, Brooke, have you got a question?
I
Yeah.
do. It's on number 7 from 15.6. I've started it out, and I just want to make sure from where I'm at, I have some big, 16 r squared cosine to the 4 theta. I just want to make
Okay.
sure I'm going about it right. At
Right,
the
let
step
me
where I'm
go
at.
in and look at the solutions to that one. So we are talking triple integrals, 15.6.
Yes, number 7.
Number 7. Right, my 7 at least will be like yours, if not the same. So what did you have in your case?
I have 8x triple integral of E 8x dv, where E is bounded by the paraboloid. Lindsay was just talking about this, and
Right.
she was so I set up the limits of integration, and I have gotten down to where I'm at two of the intervals.
Okay.
Where it's r's and cosines and sines. So
Right. Have you
dr
got
theta.
0 to 2 pi and 0 to 1?
Yes.
Then that's exactly what you should have. The
Okay.
guy in the guy that's going to be integrated has x's and z, it has y's and z's in it. Agreed.
Mhm.
In
Yep.
the version I'm looking at, it says 1 minus r squared. Oh no, 1 minus r to the 4 in brackets times the usual r dr d theta. Do you have a guy that looks similar to that? They've just pulled out a constant, so you may have 2 minus 2r4, 8 minus 8r4. You may have
So
something
I
like
went from 16. So I got it down for when I evaluated the integral with respect to x and everything. And before I made it into r cosine, r sine theta, I had the integral from 0 to 2 pi and the integral from 0 to 1 of 16 minus 16y to the 4th minus 4z to the 4th r dr d theta. And then I changed those to r's and cosine.
That's good. And
Or
you should
sines and
have
cosines.
you should have some number minus the same number r to the 4.
Okay, because I think I put in r right after I put in the cosine. So now I have 16r minus 16r squared cosine to the 4th theta. Or should
No.
r be to the 4 as well?
Yeah.
Because everything's to the 4.
Yeah.
Okay.
Let me get back to what I believe may have gone wrong here.
Okay.
Right. You're going to have your double integral. We'll not worry about the multiple because the multiples will be different depending on each question. So there might be an 8 or a 4 or whatever. You are good on the 0 to 2 pi. You are good on the 0 to 1, right? And you've done the integral and you've got something that looks like this. I'm putting in my numbers.
Okay.
Something that looks like that.
I have them to the 4th.
That makes sense. Yeah.
Okay. Okay.
But I'm going to, right, let me just wind that back a bit. You've got this guy squared first. And inside the square guy, you might have a guy that looks like this. Do you have a guy that looks like that?
Yes.
Right. Now, that's the guy you should focus on before you do anything else.
Okay.
If you do 2y squared plus 2z squared, and you replace this thing with r cos theta, square it, and you replace this thing with r sine theta, and then you square it, you will get 2r squared cos squareds plus 2r squared sine squareds. Pull out the 2r squareds, and you will get a cos squared plus a sine squared. They're 1, so you get this guy. So what that means is that your integral will now look like 0 to 2 pi, 0 to 1, some number like 2 or 4, who knows what it is, 2r squared squared. And so you end up with 4, take away 4r to the 4. Did you get something that looked like that?
No, I did not.
That's where the problem looks to me like it should be happening then.
Yeah.
It's just like polar, but we get too caught up in the fact that when we do polar, it's x and y, and x is r cos theta and y is r sine theta, and we're just familiar with it, and so it's not a big deal. But when we start switching places, so variables start taking on different orientations. In this case, it's not x and y, it's actually y and z. And that can throw you algebraically. But the
Yeah,
same
I
thing
think
is
that's probably where I went wrong, is because I did not, at that point where I was, I didn't realize that I should switch the y's and z's to cosines and sines. I
and
just
that
kept
makes
on.
r squareds, and that makes
Yeah.
your life so much easier, because really, basically, isn't that just a polynomial in R? In fact, variable separable, you can even suck out the d theta if you want.
That is true. Yeah, that's I believe where I ended up going wrong, because I ended up with like 16r minus 16r squared cosine to the 4th, and I'm like, I don't think this is supposed to go that big.
No, it wasn't meant to go
So-
that big. So your not misapprehension, your apprehension was good. It didn't look right because it wasn't right.
Okay. All right. Thank you.
You're welcome.
Have a great day.
You too. Travis, you got a question for me?
No, I just stick around and watch other people's questions.
Nothing wrong with that. I will see you tomorrow then.
Okay. Okay.
Yeah, bye-bye.